Okay, welcome back to my wild networking series where we learn about network engineering as you might see it in the wild as opposed to in a classroom or on a test. Critical to this series is RFCs. These are the public, straight from the source, primary source of information for internet standards and other network engineering concepts. So we were reading through the BGP RFC, but in doing so realized that it's just really unclear what some kinds of path attributes are meant, like what category of path attribute they fall into. So if we look at the path attribute categories, and for some reason it's not letting me do that. We can see that the RFC makes very clear in section 5 that there are 4 separate categories. However, so that's fine. When we go through all of our attributes, we see origin is a well-known mandatory. Okay, so let's slow down a bit here and take a screenshot. Okay, so now we've got the 4 categories. So let's go through all of the path attributes, because we know that path attributes fall into 4 separate categories. And let's see which category each of these path attributes fall into. So here, the first attribute we see is the origin attribute. So this falls into category number 1, the well-known mandatory category. Okay, moving on to AS path, the second attribute listed here, we can see this also belongs to category number 1, the well-known mandatory attribute. Same thing for next hop, well-known mandatory. Now, multi-exit discriminator, that's a different category. It's an optional non-transitive attribute. Category number 4. Local preference, however, is simply called a well-known attribute. And we can see we don't have a category here that says what the well-known attribute category is. We only have 4 separate and distinct categories: well-known mandatory, well-known discretionary, optional transitive, and optional non-transitive. So if they're saying that the local preference is a well-known attribute, and they aren't telling us whether it's mandatory or discretionary, we don't know which of the 4 categories it belongs to. We know it belongs to either category 1 or category 2, since it's a well-known attribute, but of those 2 categories, we don't know which one it falls into. So if you go up to the top of RFCs, you can see more information about them, such as which RFC it replaced, how it's categorized, like kind of how well accepted the RFC is. So this is a standards track RFC, the most technically accepted RFC possible. You can see some updates to it, like extensions to the RFC, but this is probably one of the most important things to look at. This is the Errata. So if there's a mistake in the RFC, you can submit corrections to the RFC for review, and if the reviewing board agrees that there is a mistake, they will make a correction in the Errata section. So the original mistake will be preserved in the actual RFC, but to see the solution to the mistake, you can go click this Errata section and see it. So if you're reading the RFC and something doesn't seem right to you, take a look at that Errata section. Hopefully it's there. If it's not, you can do what I did. And at the very bottom here, click Report New Errata. So it looks like my Errata hasn't shown up in here yet, but we can see this section, the local preference section, LOC, come on, let me do it, LOCAL. Yeah, so down here, section 5.1.5, where it is listed as a well-known attribute, but not as a well-known, nor a well-known, or well-known mandatory, nor discretionary attribute. We can see that there's already an errata pointing out that there are 4 separate categories, but the way section 5.1.5 is written, local preference belongs to a 5th category, the 5th category being well-known only. So they submitted an errata to say that the RFC needs an update to include the well-known only category. So for the origin, that's well-known mandatory. For the next hop, that's well-known mandatory. But for the local preference, that's well-known, or at least that's what it says according to the RFC. So for me, this wasn't enough, and not only that, we can see that this was rejected status, so they do not agree with this change. And then you can see some notes down here. These are all divided by this line here. So above this line, you can see some notes about what was suggested. So it says local preference is only a well-known attribute as it fails the definition for the behavior as a mandatory attribute, and it is not exactly discretionary for 5.1.5's definition of local preference and section 5's definition of discretionary. And this is a note from William McCall, who submitted this errata. So my name will show up in this if they process my errata in a public way. So in section 5.1.5, it says local preference is a well-known attribute that shall be included in all update messages that a given BGP speaker sends to other internal peers. In section 5, the beginning of section 5, the definition of discretionary is others are discretionary and may or may not be sent in a particular update message. As a well-known mandatory attribute would result in a notification per section 6.3, it cannot be well-known mandatory because it is only for internal peers. Thus, it is a separate category. If any of the, so he's saying that it's not, that it's neither mandatory nor discretionary, so it's just a well-known without being mandatory or discretionary. But what I did, and you know, reading this more carefully, what he's saying here is that it really, no matter how you look at it, it's not a mandatory nor a discretionary well-known attribute. It requires its own category. So I wouldn't personally call it a well-known attribute because that's the umbrella term. I would call it a well-known additional attribute. So you've got well-known mandatory, you've got well-known discretionary, and then well-known additional. And what I would mean by the term additional is it's an additional well-known attribute that is neither mandatory nor discretionary. So I would call it a well-known additional attribute. So in a future revision, a new term would probably be best to describe this. For me, it would be the term additional. However, the categorization of attributes is misleading for now, and the simplest approach is to add the new category already used by 5.1.5. And we can see that there's a new category here, which is well-known attribute. We've got well-known discretionary here. Atomic aggregate is an example of that. We've got optional non-transitive. Multi-exit discriminator is an example of that. And then we've got two more. We've got well-known mandatory, well-known transitive, but they're saying this is an additional category, a well-known attribute, as opposed to a well-known mandatory or a well-known discretionary. So if they honestly, if they're saying that this belongs to a fifth category, I think the new word, the best new word to use would be well-known additional attribute. And then a well-known additional attribute is a well-known attribute that is neither mandatory nor discretionary. Which, if you think about that, that doesn't quite make sense, because if it's a well-known additional attribute that is neither mandatory nor discretionary, you kind of get a little bit of a paradox, because if it's not mandatory, it's discretionary, right? Because if you're not leaving it, if you're not demanding something happen, it can happen at somebody's discretion. I guess that's not exactly right, because you can make something not mandatory. It's not mandatory that you do a triple backflip in the air and land perfectly on your feet. But it's also not discretionary, because I can't do that. I don't know people who can do that. Maybe Simone Bales or some professional gymnast, but let's say, you know, it is not mandatory that you do 100 backflips in the air. Nobody can do that. So so that is neither a mandatory attribute or a discretionary attribute, because you don't have the discretion to decide whether or not you do that. You're just not capable of doing that. So similarly, for a discretionary attribute, if you tell someone that, yeah, so I guess yeah, if you have an attribute that is not discretionary, and you say you can't decide whether or not this happens, it doesn't necessarily have to be mandatory either, because basically you just say you can't decide whether or not to go to get Chinese food or pizza, but it's not mandatory that you get either or that you even eat. So a discretionary attribute, where it's up to the update message of BGP whether or not to send it, does not mean that the update message needs to do either action. If that, I'm not sure if that makes sense, but it's basically, I'm trying to kind of think about a well-known attribute that is neither mandatory nor discretionary, and I think I did a good job with one that is. I think the best example of that would be an attribute that is not mandatory, but it's not discretionary either, because it's not up to you whether or not to do it, because you're just not capable of doing it. But obviously the local preference wouldn't fall into that additional category, because it is capable of sending a local preference. So it's so that's why so what I did, and I'll show my email on this, but look, before we move on, let's read the verifier notes. So this errata was discussed on the IDR list. I think mine is being discussed on the IDR list as well. here's my errata. We'll get to this in a little bit. The consensus was that whilst an alternative is to revert from open sent to idle on event 18 at that point, this was not what was decided when RFC 4271 was being produced, and no one saw a good engineering reason to change it at this stage. In a matter of process, this proposal is not an erratum as the IETF sees it, but an engineering change. The submitter is, of course, welcome to submit a draft proposing this change to RFC 4271 and the two discuss the merits of the change with the IDR working group. So you can see here, this is kind of shocking. This is a widely used protocol that every vendor is required to include on their when they run BGP. Every vendor is required to have the local preference included in that, because we know it's a well-known attribute. We don't know whether it's mandatory or discretionary from the RFC, but we know it's well known. So they're requiring every network vendor to include this. But when a very, very understandable correction is submitted with very clear direction as to what the problem is, that they're not saying whether it's mandatory or discretionary, and that needs to be known. And the notes not only don't appear to address this at any time. I mean, an open sent message, that's not that these would be established connections, neighborships. So an open sent neighborship, they're talking about the formation of the BGP neighborship, which has nothing to do with the sending of a BGP update message. The formation would have already been established, and you wouldn't have a reversion of open send to idle if you were talking about the exchange of the local preference path attribute. You would have a solid established neighborship, and then you would have a exchange of TCP data over that neighborship. So what they're talking about here appears to be just completely unrelated to. I almost wonder if they mixed up the notes and they posted this in the wrong way. And I think there's more evidence to that, because we can see there's a grammatical error here, and the to discuss. So clearly this response to this very clearly stated errata is just not, I think, a serious response. So I, after having read this, skimmed it through, I submitted an errata because I wanted a more clear response to this, because I just wasn't catching on to this RFC, and I want to learn BGP. So what I did is I said, here's my errata. So the original text was local preference is a well-known attribute and shall be included in all update messages that a given BGP speaker sends to other internal peers. So I submitted I submitted a correction to that text. The correction I submitted was local preference is a well-known discretionary attribute that shall be included in all update messages given to a BGP speaker that a given BGP speaker sends to other internal peers. And the reason I included that is because we've seen that. We've seen messages in the lab where local preference wasn't included in the BGP update message. So therefore it must be discretionary, because or the Juniper routers violated the RFC. They created an implementation that wasn't what the RFC had intended, if the RFC intended it to be well-known mandatory. And that's the point of contention, but from what I could see and from what I gathered, local preference really fit the mold as a well-known discretionary attribute. And not only that, this word shall here, I interpreted that word more as like a colloquial definition, where if it shall, that means it shall not. Discretionary. If it shall or it shall not, or if the router has the ability to decide whether or not that attribute is included in all update messages that a given BGP speaker sends to other peers, to me that means that it's discretionary. So here's the response, and let me read the notes I included, because I think those make it even more clear. It is unclear from the text which of the 4 attribute categories local pref belongs. So we see well-known mandatory, well-known discretionary, but in the text it says it's well-known attribute. There was even submitted an errata to create a 5th category for this attribute, but it is clear from the definition of the categories that this attribute is well-known discretionary. All routers must be capable of sending or receiving the local pref attribute. However, it is up to a router's discretion whether to include that attribute in an update message. So here's the response I got. Shall is the same as must or required in RFC 2199. So if it must be included, how can inclusion be discretionary? So let's look up the word shall in this RFC. Okay, so it looks like shall is not, okay, so yeah, so it looks like shall is the equivalent of required, is the equivalent of must. There's 3 words that mean that the definition is an absolute requirement of the specification. So we can see here that shall, this means must. So it must be included in all update messages that a given BGP speaker sends to other internal peers. There we go. So well-known mandatory, right? Because it must be included in all the messages sent to internal peers. But it's not included in messages sent to external peers. So I guess this is where there's still a matter for debate, because you can see what my response was to that is, if it must be included, how can inclusion be discretionary? I don't think it can. I think you're right. It must be included, so therefore it's not discretionary. Therefore it falls into the other category of well-known, mandatory. So if it's not discretionary, we know that it's mandatory, right? Because that's the only other category of well-known attribute there is. And if we know it's not discretionary, we know it falls into that other category. So here's the response. Thank you. Please update the sentence from this. Local pref is a well-known attribute to this. Local pref is a well-known mandatory attribute. To that, I have not yet received a response, but there was further discussion on this, aside just from what I received initially. And we can see here, I was right to consider this discretionary, because it is up to the router's discretion. Let me put it this way. Alvaro agrees with me that it is a discretionary well-known attribute. And I right now, I'm on the fence with that. I still kind of leaning towards that. I think it is a well-known discretionary attribute. But the thing is, and what makes it really unclear, is I do understand and believe that it's a well-known mandatory attribute in the context of iBGP. Any iBGP update message has to have that in it. But since we're talking about BGP v4 and we're not talking specifically about iBGP or BGP, I would consider this a discretionary attribute because it's up to the router's discretion whether or not it's included in an update message. And the discretion of the router was that what was determined so that the update messages sent to iBGP peers include the attribute all the time, regardless, as if it were a mandatory attribute. But the update messages to eBGP peers do not include that message. So I do consider that a discretion. The router includes that path attributes for iBGP connections, but doesn't include it for eBGP connections. It uses its discretion to decide when it is included for which type of neighborship. And you can see Alvaro really makes that case clear here. RFC 4271 defines discretionary as simply the fact that the attribute may or may not be included in all update messages. All update messages, including iBGP and eBGP update messages. From that point of view, the type is well-known discretionary. However, using discretionary with a required action can also cause confusion. I think the report is valid, but I also don't think it should be marked as verified. Instead, it should be marked as hold for document update. Does anyone object to this classification? Okay, so I might actually do another reply to this and just say, thank you, Alvaro. I definitely agree that. So let me do this. Let me reply, and I'm gonna say, thank you, Alvaro. I definitely agree that local pref is best. This best fits into the fourth category. Well, no, the second category of path attribute, well known discretionary. Okay, thank you, Alvaro. I definitely agree that local pref best fits into the second category of path attribute, well-known discretionary. Although in the context of iBGP, this attribute must be included. RFC they want it. It looks like whenever they say RFC, they put it in brackets. So I'm going to follow that convention if I see it again. Let me see what Alvaro said. No, he didn't put it in brackets. Okay, I'm not going to put it in brackets. Okay, so here we go. Thank you, Alvaro. I definitely agree that local pref best fits into the second category of path attribute, well-known discretionary. Although in the context of iBGP, this attribute must be included. RFC 254 is not specifically does not apply to, does not specifically apply to, although in the context of IBGP this attribute must be included, RFC 4271 does not specifically apply to such context. It applies to BGP -4 in totality, or in totality. Okay, so I agree. Thank you, Alvaro. I'm going to say I agree. I agree that local pref best fits into the second category of path attribute, well-known discretionary, although in the context of IBGP, this attribute must be included. Although in the context of IBGP, this attribute must be included, RFC does not specifically apply to such context. It applies to BGP for in totality, and the router makes a discretion to include the attribute in all IBGP update messages, but no eBGP messages. Thank you for the thank you, Donald, for the clarification of the term shall. Okay, thank you, Alvaro. I agree that local pref best fits into the second category of path attribute, well-known discretionary. Although in the context of IBGP, this attribute must be included, RFC 4271 does not specifically apply to such context. It applies to BGP-4 in totality, and the route makes a discretion to include the attribute in all IBGP update messages, but not in eBGP. Update messages. Thank you, Donald, for the shell, but as the mandate only applies to a specific aspect, thank you, Donald, for the clarification of the term shall, but as the mandate only applies to a specific aspect of BGP-4 and not in totality, as for the well-known mandatory attributes of origin. What was the other one? AS, path, and next hop. Thank you, Donald, for the clarification of the term shell, but as the mandate only applies to a specific aspect of BGP-4 and not in and not in totality, such as for the well-known mandatory attributes of origin, AS path, and BGP. I believe known discretionary to be a better, I believe well-known discretionary is the more accurate category, as the router makes discretionary choices for update messages sent to either iBGP or eBGP peers, even though each router manufacturer happens to consistently even though each router manufacturer and even though each BGP, even though each known BGP before implementation happens to consistently make the discretionary choice in the same way, giving the appearance of a mandate. Okay, so thank you, Alvaro. I agree that local preference best fits into the second category of path attribute, well-known discretionary. Although in the context of iBGP, this attribute must be included, RFC 4271 does not specifically apply to such context. It applies to BGP-4 in totality, and the route makes a discretion, and the specific BGP implementation, does make a discretion for does make a discretion to include the attribute in all to disclude the attribute as the RFC Okay, it's the wrong RFC. Huh. Okay, I wasn't expecting it to say must not include this attribute in update messages. Huh. Yeah, this is tough. Okay, I guess I would say since there's okay, so let me say this. It applies to totality, and the specific BGP implementation does make a discretion to disclude the attribute in all EGP update messages, unless the chosen design of the autonomous system includes route Okay, so let me read this again. Thank you, Alvaro. I agree that local prof best fits into the second category of path attribute, well-known discretionary, although in the context of IBGP, this attribute must be included. RFC 4271 does not specifically apply to such context. It applies to BGP-4 in totality, and the specific BGP implementation does make a discretion to disclude the attribute in all eBGP update messages, unless the chosen unless the design of the autonomous system includes RFC to the Bgp Confederations. Okay, I think that's good. Thank you, Donald, for the clarification of the term shall, but as the mandate only applies to a... Okay, and this is false. Must not applies to... but as the mandatory element only applies... Okay, thank you, Don, for the clarification of the term shall, but as the mandatory element only applies to specific aspects of BGP -4. Oh, but then you get VPNs in there too, because you have to have... I'm so confused. Right now I'm just like really confused, and it's been 45 minutes into just writing an email to somebody. And it sounds like they're going to. It sounds like they're going to figure. Like they're discussing it anyways. Okay, so I think I'm gonna send this. I should probably stop working on this, but I say I agree that local path best fits into the second category of path attribute, well-known discretionary. Although in the context of IBGP, this attribute must be included, and in the context of eBGP, this attribute must not be included. RFC there is an exception for there is an exception for EBGP. There is an exception for RFC. With the exception of BGP, with the router discretion, with the router discretion of Bgp Confederation, with the discretion of BGP setup, Okay, I think I'm good with this. Thank you, Alvaro. I agree that local preference best fits into the second category of path attribute well-known discretionary, although in the context of IBGP this attribute must be included, and in the context of eBGP this attribute must not be included. There is an exception for RFC 3065 BGP configurations. There are no such exceptions for the other well-known mandatory attributes, origin, AS path, and next hop. Well-known discretionary next hop as the router can make discretionary choices for update messages based upon whether or not Bgp Confederation is configured. Local pref is a well-known discretionary attribute. Okay, let me read this one more time, and I'm gonna click the send button, and then maybe just like scream or something. I don't know. Well, I won't scream because I don't care that much, but I would maybe just like ice my brain. That's a better way to put it. Thank you, Alvaro. I agree that local pref best fits into the second category of path attribute, well-known discretionary. Although in the context of IBGP, this attribute must be included, and in the context of eBGP, this attribute must not be included. There is an exception for RFC 3065 BGP confederations. There are no such exceptions for other well-known mandatory attributes, origin, AS path, and next hop. Because the router can make discretionary choices for update messages, because the router can make discretionary choices for the update messages for the local pref path attribute because the router can make discretionary choices for the local path attribute in update messages based upon whether or not BGP configuration is configured, local pref is a well-known mandatory attribute send. Okay, that I'm done doing that. So that took me an hour, but I pled my case. I am 80 to 90%. Well, I don't know. I'm still a little bit on the fence because I think it could be either, but just the fact that you sniff a message and any message you sniff, doesn't have it, to me is evidence that it's well-known discretionary, because that's not true for the origin, the AS path, and the next hop. Anytime you put a Wireshark sniffer out there and get the packet, it's going to have those three attributes because they're mandatory well-known. For local preference, if you sniff a IBGP connection, you'll only see it, but an eBGP connection, you won't see it unless there's an exception for BGP configuration, and that's where I believe there's discretion. So that's why I think it's well-known discretionary. But I could understand an argument that there's actually not discretion there, even though so first of all, it must be included in all IBGP, and it must not be included in eBGP. So there's no discretion there. You can't make a choice as to whether or not you include it. The choice is already made for you. If you choose IBGP, you must. If you choose eBGP, you must not. There's no discretion there. Your only discretion is whether or not you configure an IBGP or an eBGP connection, but the discretion for how to handle local pref is different than that. It's not based on that decision. Once you make that decision, it is mandatory, and there is no discretion in that. Likewise, for Bgp Confederation, in the case of Bgp Confederation, you can send local preference to an eBGP peer, but where I could understand a counter argument to me saying that local pref is a well-known discretionary attribute would be the argument that even in the exception of Bgp confederations, in the same way that it is mandatory to configure the behavior of the local preference based on whether it's an IBGP or BGP connection, it is also the same to configure it whether it's a BGP confederation. Therefore, it's a well-known mandatory attribute, because even though you have separate situations in which you could configure it, depending on the situation you choose, it's mandatory how you configure it. And that would be different from the atomic aggregate, because we can see that we've got this word should here. So we don't have any such word in local pref, because it's always mandatory what you do with the local pref. You just have different situations that apply different mandates, which is different from other well-known discretionary attributes such as local preference. So that I could understand as an argument for it being a well-known mandatory attribute. And then, of course, I also understand the argument for it being a fifth category. And I think just the way it reads now, that errata of it being a fifth category just makes a lot of sense. But I'm on the side of the fence of well-known discretionary right now. But I could be talked out of that. I don't know. I'm gonna pause it and come back, and then we're gonna we're gonna try to get back on the rails here and actually read through some more of this RFC. So I'll be back shortly. All right, so I'm back from my break. I am going to continue on with section 6 of the RFC, even though I'm really kind of glossing over section 5.1.6 and section 5.1.7. I will be totally honest, I don't understand these attributes. I wasn't able to find these attributes in the lab. So you know what? I'm gonna do myself a favor here and not skip that over. So let's do Juniper, atomic aggregate Juniper, configuring route aggregation. Here we go. So let's try to get this showing up in the lab. So now these guides here have really, I'm really not a fan of them. They've left me high and dry during the test. I wasn't able to do well on the test just by following these guides, but let's see what we can do just by following this guide here. Okay, so let's follow the action. Well, let's set up the config here. So they've got multiple routers here. Their topology has 4 routers in it. You know what? Let's just do that. Let's just mimic their exact topology. We're gonna make a new one, and we're gonna do. We're gonna name it route aggregation. There we go. And then we'll just do exactly what they have. That'll be easier, I think. Because my goal is just to capture the packet right now. This is not my JNCIE SP retake series. I won't be doing an actual series for that because I can't talk about what I've seen on the exam and I don't want to take a risk with that. But what I will be doing, I think, although to be honest, I discussed this before and I just don't really feel ready for that kind of level of exam right now. And not only that, my retakes are next year. I'm going to need to crunch to recert next year, so I might be better off just trying to recert, because I'm going to have to recert in Cisco and in Juniper next year. So just focusing on my recerts might be a better idea for me than trying to get an IE cert, especially since I didn't do well enough to really warrant a retake anyway. So all right. We can see with my new lab running on KVM, they boot up right away pretty much. Okay, so I think I'm gonna pause it. Well, I don't know. This should only take like 5 minutes. Let me see. Right now I'm at the hour and 3 minutes mark, so it should be up by the hour and 8 minutes mark. Oh, it seems to be a little bit slower than usual right now. Maybe because I still have my other lab, my other project open. Yeah, I have some other projects open, so maybe that's why it's taking longer. Let's see here. Oh, I'm gonna pause it. I'll be back soon. Okay, I'm back from my break. I do have a. I took a break because I was waiting for the lab to boot up, which we can see it is boot up now. It has booted up now. So let's try to get through the example here from Juniper and capture an atomic aggregate packet. Or sorry, capture a packet that has an atomic aggregate path attribute in the TCP data payload. Okay. Delete. Okay, so I'm going to do this as fast as I can possibly do it. Okay, so unit 1 isn't going to work. Juniper has this mistake on like all of their documentation. I submitted a errata for it, but oh yeah, so it looks like that mistake is on that one as well. So let me copy this and move it over, and then fix that mistake. Come on. There we go. Alright, and I do need to do something at 1, but hopefully I have enough time just to bring this example up. There we go. Okay, and I think this was 1 and 2 on here, so I'm just going to recable it. 1 to 0, and then 1 to 0. To 0. Delete, and then 1 to 0. Okay, there we go. So that was right. Okay. Back. Oops, there's a TH. Well, I don't see where that TH is. Oh, okay, didn't paste in this time. Alright, perfect. Alright, one more, ready to go. Okay, so we've got the lab configured now. Let's take, first of all, let's rename this to ISP, just so it's more clear. Okay, and then let's do a packet capture. Now we know that this is a well-known discretionary attribute, but unfortunately it doesn't tell us whether it's sent in eBGP or iBGP updates. So we'll start with the, I assume this is a eBGP link. It'll be in red if it is. Yep, so it's in red. And then side by side, let's do the iBGP. That should be in yellow. It's in yellow. Oh, that's OSPF packets though. Oh, right, we're not going to have any. Oh, no, we are. Okay, here it is. Yeah, we see it's in yellow. So let's get an update message going. So to do that, we're going to need to bounce the port where those so wherever those messages originate, we'll need to remove them and then re-add them, and we'll get an update message. So unfortunately, there's not any, there's no update messages, so we're not getting any path attributes. But we just know from the design of the exercise what to do. So I just need to shut and no shut loopback 0. Okay, and we'll get a withdrawal route. Or sorry, we'll get an update message with the withdrawal route. I think, unless we won't. Oh, you know what? We probably won't because we're advertising an aggregate, so it doesn't consider the specifics. So what we're going to need to do, yeah, I don't even have one in iBGP, but what we're going to need to do is flap the aggregate, not the specific route. Yeah, because this is a specific route, so we're going to need to flap the aggregate. The aggregate, I believe, is on the router on the autonomous system border, so R3. Okay, so here's the export policy to send the aggregate, and then the aggregate is here. So let's delete this export policy, and we'll see the aggregate route being withdrawn. Assuming it works that way, I think it does. But that's the point of this video, is to find out. Aha! So I was right. We've got the upgrade message, and we've got NLRI withdrawn routes. What's interesting is we have path attributes. Oh, I see. Because we removed the aggregate, it's going to learn the specific routes. So the aggregate was 10.200.0.0. Oh, and it looks like we also sent a default route. But let's roll this back and see what happens. But you can see now we're learning the specific 10.200.2.1 and 10.200.1, sorry, .2.0 and 10.200.1.0. We're learning those specific addresses that were configured on router 1 instead of the aggregate address. So let's roll back that change and take a look at the update message that replaces those routes with the aggregate routes. Before doing that, I'll quick show. I'll prove that, yeah, so we can see here's those routes individually, and then here's the aggregate of those routes, and we can see from protocol aggregate. So in addition to that, we've got to actually make the aggregate route here. The same way we would make a static route, you make an aggregate route. An aggregate route is a different kind of route, like an OSPF route, a BGP route, static route. You also have aggregate routes. So the first thing you got to do is make the aggregate route. The second thing you've got to do is make the policy to send the aggregate. So you're going to take from protocol aggregate, then accept. And it looks like you've got to go even further than that. You've got to suppress specific. Oh, so after you, so if you don't, if that's all you do is you advertise the aggregate route, what will happen if you'll get the specific routes and the aggregate route as well. So you've got to make another term after you create a term to send the aggregate route to not send the specific routes. So you don't get both the specific routes and the aggregate route. And then in addition to that, it looks like they have another policy statement to send a default route. I'm not sure why they're doing that. That's interesting. But we're going to roll this back, commit, and get the update message. There it is. So we've got our well-known mandatory attributes, origin, ASPath, and xhop. And now we've got our well-known discretionary, so we've got our aggregator attribute, which is a optional transitive attribute. And transitive, as I discussed in the last video, a better word for that would be shareable. So this attribute here can be sent to other autonomous systems. Okay, so this is my goal. I wanted to see both of these. Right now I've got the aggregator capture, but I would also like to see the atomic aggregate capture as well. But you can see here in our network layer reachability information, now we just have this one aggregate route instead of the specific routes. So if I were to go back to the lab here and what can I do? Let me try removing this specific routes here, and then I think I'll get a update, and then we'll have both the aggregate routes and the specific routes being learned. So before I do that though, I'm gonna open this router here, this ISP router, and then take a look at what we've got in the BGP table. Okay, so I'll put that on a refresh. You can see right now we've got the one aggregate route. Okay. So if I delete this policy here, we'll have not only the aggregate route, but the specific routes as well, which obviously is not something you would want. The point of having an aggregate route is to not have those specific routes. So here we have 3 routes, no good. Let's roll that back. And we're back to the single aggregate route now. Okay, and just to kind of make another point, oh my God, my foot. What I'm going to do is, I don't know why my foot just all of a sudden out of nowhere like hurt really bad. I wasn't even doing anything. It doesn't hurt anymore. But what I'd like to do is roll back What would I like to do? Let me think here. Oh, I'd like to get rid of this export policy just so we have the specific routes, and then disable one of the specific routes and see a withdrawn message for that. So let me do that right now. Okay, so now I'll get an update message. Here it is. We've withdrawn the aggregate here. We see that. But then we've also added the specific routes now because we are sending those to we are sending those via BGP, and I believe we're doing that because of configuration on router 1. The hell? Or not. Okay, I wasn't expecting these two routes to be learned actually. Okay, so here's clearly a problem with my understanding here. I did not think these routes would be in here because I did not think they were, because they're not being advertised into BGP. But I think there's like a default behavior in BGP where they do get advertised over, and the default behavior is like a route that's in iBGP gets advertised to eBGP, but I don't know how it would be in iBGP. Okay, let me do a filter for update messages. So I'm going to go click on the update I had up here, and then we'll filter out for this type. So I'll do prepare because I don't want to apply it to this capture, I want to apply it to the other one. We don't have any update messages. Oh, so it is learning this through BGP. I thought you needed a policy in BGP though. I thought you needed an export in order to, like, I thought there would be an export on R1. Oh, maybe because it's external? But why is it not learning this one? Maybe it is. No, it's not learning that one. Oh, no, it is. It is learning that one. Right here. Okay, perfect. But why is it learning that one as OSPF, but not as BGP? Oh, you know what? I think it is learning it as BGP. It's just OSPF has a higher administrative distance, so BGP doesn't show up here. Okay. Okay, I think I'm catching on. But there's definitely a gap in my knowledge here as to when and why routes are distributed through the BGP protocol, the Border Gateway Protocol. All right, so I guess I kind of want to move on from this. My goal really was just to find the path attribute in Wireshark in the capture to be able to capture that somehow. And I saw how I can capture the aggregate attribute. The way I can do that is by creating an aggregate route, just like you would create a static route, and then creating a policy to export that aggregate route into BGP. So it would just be from protocol aggregate, and there would be two, and then it would be then accept. It's just a two-statement policy that we can see here on router 3. There we go, just a simple two-statement policy. Let's roll back the changes I had on here. Okay, but in addition to that policy, you need another policy that denies the specific routes from being sent. So we can see here we only sent the aggregate. That's because we have an additional we have an additional term within our policy, and it's just a two-statement term, and that's if it comes from this and it's going to be longer, not or longer, because we do want to match on this, then we're going to reject them. So there we go. And then we've also got a default. I don't know what that's all about. Does it have a default route? It does. Okay, so that's what it's all about. Oh, wait, but it's got a static. Oh, it doesn't have it because so it's got a static route configured. Let me see here. Yeah. So it's not receiving the default route. If I were to delete this, then we would get the default route. Let me try that. Okay, now when I look at the routing table, we'll have the same route that I just deleted, but instead of protocol static, it'll be protocol BGP. And we can see, oh, it looks like I got another update, but I'm not sure. Oh, because it withdrew. Oh, I think it was advertising that. But let's see if I'm right here. I am wrong. I am absolutely wrong. And I was fairly sure of that too. So that's our problem. I am not an expert in BGP at all. This is why I'm, again, really thinking about whether I want to do a retake of the JNCI ESP, because am I an expert? Am I deserving of expert level certification? Probably not this year. If I just recert my CCNP and my JNCIP, and I get another 2-3 years of professional experience, you know, at that point I might be more. It might be more appropriate for me to have an expert level certification. But I'm really kind of starting to think that at this point in my career, with you know, I guess 6 years of professional experience, I'm just not sure I'm at an expert level with that much professional experience. I'll probably need a few more years before I can really call myself an expert. Okay, so let's see here. We've got, yeah, so we've got a problem here. The configuration is different than how I thought it would be, but it's not a technical problem or a problem with the configuration. It's just a problem with my understanding. So I just need, so that's easy. I just need to have a better understanding of what's happening. But we can see on the other side, we did receive this route. So we did receive an update message adding it back. So this isn't all for naught. We are sending it back the other way. See, and I don't know what we need this for, because, you know, this is an export policy, not an import policy. So I wonder if we'll receive that if I remove this statement. because it's just weird that it says send default when there's no default to send. I almost wonder if they meant to have it on this side, but it looks like this is a mistake in the documentation, and it only serves to make things more confusing. In fact, if I go ahead and remove it, we don't even get oh, I see. Okay, now I understand. So the reason for this policy is because we received a default route from the ISP. So let's take a look at that. Show route receive protocol BGP, and then I don't know the neighbor. Show. Let's just do show route protocol BGP. So here it is. We received it from the ISP, and let's do that show route receive protocol as well. Show route receive BGP. That's it. That one. Oh, right, because the next hop is the address on the other side. So yeah, here we go. Here's what we received from the other router. It's an eBGP route, so we've got a AS path building out because it traversed ASs. And then the origin attribute I, they're always going to be I. So if we look at router 1, you can see, what? Oh, okay, so router 1 is in a different autonomous system. Yeah, router 1's in a different autonomous system, so we're not going to be, so no, why is router 1, this is so weird. I don't think this is not at all what I was expecting from this example. And I think the reason for that is just I don't understand this very well. I'll be the first to admit it. I really did poorly on the JNCI ESP, so I've got a lot of work to do to understand this better. Okay, I think I'm gonna end the video now. I've got to get to that thing at 1. So stay tuned for the next video where I try to get the atomic aggregate. I might spend a little bit more time on this just to kind of understand this example a little bit better, but it's kind of getting off track. I really want to just get a capture of this atomic aggregate before moving on to the next section. I was able to capture every other attribute but that. Alright, so thanks for watching and see you in the next video.